All right, so what can we do with this one? This one is, I think, number 5 in the homework. And we're going to use the alternate definition here. And I need to calculate what is f of 5, which is 4 over 5 squared, or 4/25. And for most problems, I would recommend using fractions, not decimals, because decimals sometimes force you to round, and then rounding introduces error, which could cause you grief. So bear with it with fractions, you can do it. So here's my definition. I'm trying to do that right there. So let's see. Limit as x approaches 5 of the fraction f of x. Well, this is my f of x right there. So 4 over x squared minus f of 5. And that's 4 over 25. And in the denominator, I just have x minus 5. What do we do with this? Well, I'm going to ignore the limit for a minute and just work on cleaning up this fraction. And thinking back to my algebra days, if I have a complex fraction like this, I need to get rid of the fractions in the numerator, denominators in the numerator here. So we need a common denominator, which would be x squared times 25. That's about all I can do. So here I want to multiply top and bottom by 25. And here I want to multiply top and bottom by x squared. So ignoring that limit for a minute, we get 25 times 4 is 100 minus 4x squared over common denominator of 25x squared. And all of that is over x minus 5. If you take a fraction and you divide, that's the same thing as multiplying by the reciprocal. The reciprocal of x minus 5 is 1 over x minus 5. So this becomes, take that original numerator fraction times 1 over x minus 5. And nothing cancels at first, but I do notice that this thing right here should factor, because it's the difference of two squares, right? 100 is a perfect square, 4x squared is a perfect square. So I get 100 is 10 times 10. And 4x squared would be 2x times 2x. And if that's a negative, one of these must be positive and the other one must be negative, like that. And that's all over 25x squared times x minus 5. Right, my denominator over here combined, multiply denominators. Okay, well, other thing I notice is that 10 and 2 are even, so I can factor a 2 out of this, and I can factor a 2 out of that. So I'm going to factor a 2 out of the first one and a 2 out of the second one, and that leaves me 5 plus x times 5 minus x, all over 25x squared times x minus 5. Oh, this is nice. Check this out. These two are very similar. Let's highlighter this one and this one. Notice the subtraction is just opposite. If you change the subtraction, you just change the sign, right? 5 minus 8 is negative 3, 8 minus 5 is positive 3. So these guys right here will always factor, always lead to negative 1. So those cancel as a negative 1 instead of a positive 1. And that was helpful. So what do I have now? Negative 1 times 2 times 2. So we have, let's switch color. We have a negative 4 times 5 plus x. And that one's gone. And then in the bottom, we have a 25x squared. 25x squared. And that's about all I can do. So I'm ready to bring that limit back. Limit as x goes to 5. So we just plug in and hope nothing goes wrong. By the way, if we tried to plug in 5 at any other point here, we would find 0 over 0. And we'd have to say, oh, better do some more algebra. All right, so if we plug in 5, we get -4 times 5 plus 5 is 10. Over the bottom, we get 25 times 5 squared, which is also 25. And does this clean up at all? I think it does a little bit, right? 5 goes into 10 twice, and 5 goes into 25 5 times. 2 times 4 is 8, so I get a -8. And 25 times 5 is 125. So I think this is the slope when x equals 5 on f of x equals 4 over x squared. And to check that, we graph the tangent line. And the tangent line would be that y minus y1 equals m times x minus x1, which we've done before. So if we do that here, we get y minus y1 is 4/25 equals the slope -8 1/25 times x minus 5. And again, I got that graph ready to go here. Here's that graph. Here's my f of x equals 4 over x squared at the point 5, f of 5. And that's right there. And this is a rounded version of that. No, it's not. 4 over 25 is 0.16. And then here is my point slope version, which gives me this green line, which only touches this curve at that point. It doesn't pass through the curve, it just grazes it. And so that looks like a good tangent line, and you could zoom in there to double check. Oops, wrong button. To see that these two look good. The red is always going to be on top, the green is underneath, and they match. The green line matches the slope of the red curve when x is 5. Well, that was exciting.